Good day everyone, I'm Daño and today I will discuss about acid and base. Objective: to determine the concentration of an acid or base. Acid-base titration. Titration is the process of adding a measured volume of an acid or base of known molarity, or also known as the standard solution, to an acid or base of unknown molarity until neutralization occurs. So an indicator is added to the flask. It changes color when neutralization has occurred. Titration is used to determine the concentration of acid or base by adding base acid of known concentration, or also known as titrant. For most titration, the titrant is slowly added from a burette into a known volume of sample solution in the receiving flask. The titrant is added just until all the reactant in the sample is consumed, or also known as equivalence point. What is an acid? The substances which are sour in taste are called acids. Curd, lemon juice, orange juice, and vinegar are acids. Their chemical nature is known as acidic. Any substance is said to be acids when its blue litmus paper changes to red color or pH value is less than 7. And here are the other definitions of acid. The acid is a chemical substance that have a pH lower than 7. It's like a substance that is liquid at the touch, with a sour taste, and even can turn blue if it mixed. It can react with substance with 7 or greater pH, base, and many metals. A lower pH, it means higher acidity. And lastly, it's a positive form of base. Strong and weak acids and bases. Strong acids are assumed to dissociate completely when aqueous solution, while weak acids dissociate only slightly in aqueous solution. The majority of molecules remain undissociated. Dilute versus concentrated acids. Dilute acid is a small amount of acid per unit of volume. The amount of space the solution takes up is measured in ml, while the concentrated acids are a large amount of acid per unit of a volume. The strength of acid and concentration of acid are separate properties. You can have a strong dilute acid. You can also have a weak concentrated acid. Concentrated and diluted acids. The concentrated acids, there are more acid added, while in dilute acid, there are less acid added. The purple represents the hydrogen ion, while the red represents the negative ion. What is a base? A base is a solution that has an excess of hydroxide ions. Another word for base is alkali. Bases are substances that can accept hydrogen ions. And here are the properties of bases. So what is a base? A base is any substance that produces hydroxide ions in water. So bases share several characteristics, and these are: bases have a bitter taste, bases feel slippery, bases turn red litmus blue, and bases do not react with metals or carbonates. And here are the differences between acid and base. The acid has a sour taste. It turns blue litmus red. It reacts with some metals to produce hydrogen. It also dissolves carbonate salts, releasing carbon dioxide. While the base has a bitter taste. It turns red litmus blue, and it is slippery to the touch.
Really just a measure of how acidic or alkaline a solution is, and it's measured on a scale from 0 to 14, with low numbers being most acidic and high numbers being most alkaline. And if the substance is neutral, like pure water, then the pH would be 7, which is neither acidic nor alkaline. To give you some idea of what all of this means, the acid in your stomach, which helps you to kill bacteria, has a pH of around 2, while acid rain is around pH 4. Then for alkalis, washing up liquid has a pH of around 9, and the bleach we use to clean bathrooms has a pH of around 12. Be aware though, you don't have to remember these specific examples, they're just to give you some context. Now we can measure pH in a couple of different ways. One is to use some kind of indicator, which are a group of chemical dyes that change colour depending on the pH, and different indicators will change colour at different pHs. Some indicators contain a mixture of these different dyes though, so their colour will slowly change across a wide range of pHs. So we often refer to them as wide range indicators. The most common example is universal indicator, which gives the colours we've shown on our pH scale here, ranging from deep red at a very low and acidic pH, to yellow, green, and then bluey purple as we increase the pH and it becomes more alkaline. The other way to measure pH is to use a pH probe connected to a pH meter. By dipping the probe into a solution, we can electronically measure the pH and get a numerical reading on the meter. The benefit of the probe compared to an indicator is that it can be much more accurate and precise, because it doesn't involve humans guessing shades or particular colours. And as a general rule, measurements that remove the need for human judgment are going to be more reliable. The next thing we need to look at is what exactly makes something an acid. You can define an acid as any substance that forms aqueous solutions with a pH of less than 7. And the reason for this is that acids release hydrogen ions in water, which make the solution acidic. On the other side of the scale, we have bases, which we define as any substance with a pH greater than 7. Meanwhile, alkalis, which we mentioned before, are actually a subgroup of bases that are soluble in water. So we would say that an alkali is a base that dissolves in water to form a solution with a pH greater than 7. And these alkalis form OH- ions in water, which we call hydroxide ions. If we react an acid and a base together, then we get a neutralization reaction, which will always produce a salt and water. For example, hydrochloric acid plus sodium hydroxide, which are the most common acid and base, will react to form sodium chloride, which is a salt, plus water. Another way to show these neutralization reactions is in terms of hydrogen ions and hydroxide ions, where H+ from the acid and OH- from the base combine to form H2O. And because the acid and base have both been neutralized in these sorts of reactions, the pH of the products should be 7 because they're neutral. Before we finish, I just want to point out some of the common acids and bases that you'll come across in the course. The main acids are hydrochloric acid, sulfuric acid, and nitric acid, while the common bases are generally hydroxides or carbonates, like sodium hydroxide or calcium carbonate. There are loads more, but it's definitely worth learning these few, as they crop up a lot.
These can be generalized as stronger acids and bases tend to react with each other to produce their weaker conjugates. The stronger a Bronsted acid is, the weaker is its conjugate base. The weaker a Bronsted acid is, the stronger is its conjugate base. So these ideas can be applied to the binary acids, which is the acids made from hydrogen and one other element.